Hey guys, Jake here coming at you with another math lesson today. Today we're going to continue our discussion of advanced differentiation techniques from my book, The Elite Guide to AP Calculus AB. Go scan the QR code up in the corner or check the link in the pinned comment or description below if you want to grab yourself a copy. It's available on Amazon, so go check that out. But today we're going to be discussing higher order derivatives. Up to this point, we've pretty much only discussed first derivatives or the derivative of a function. I do just want to kind of touch on higher order derivatives. So essentially what higher order derivatives means is just second, third, fourth derivatives of a function. Anything above just taking the derivative of a function. You can take, second, third, fourth, really any number derivative of a function. Now, all that really means is to take the derivative of a function, then take that function's derivative, and then keep going as many levels as you need to get whatever you're being asked to find. So essentially, if you have some function f of x and you want to find its derivative, that would typically be denoted as f prime of x. That's basically just using the different, derivative techniques that we've discussed up to this point. If we then wanted to take the second derivative, for example, we would just take whatever this f prime is and take the derivative of that. So taking the derivative of f prime would give us f double prime of x. And you could keep on doing that over and over and over. Just quickly to kind of note a notational thing, let's say we wanted to find, in theory, let's just say we wanted to find the sixth derivative of a function. Really, AP calculus only really uses the first and second derivative of functions in general. If you get on to kind of more advanced calculus, later on in college or whatever, you might have to find higher order than even the second derivative. So just kind of a notational thing. Let's say we wanted to find the nth derivative of a function. That would be denoted as like this. F with this little n or whatever the number is in parentheses. So let's say we wanted the sixth derivative, for example. That would be written like this. That would show you the sixth derivative of f. But like I said, really in AP calculus, we're really only going to be using the first and second derivative. There might be occasions where you're asked to find higher order derivatives than that, really just for the sake of showing that you can find the derivative of a function multiple times. But really the kind of applications, which we will get into in a future video, mainly concern the first and second derivative. But let's go ahead and discuss this problem here just to kind of demonstrate these higher order derivatives. We're going to determine the third derivative of g of x equals 5x to the fourth minus 2x squared plus x. So like I said, to find the third derivative, we essentially would just want to start with finding the first derivative. So g of x is this function here. First, we would find g prime of x, which would be the first derivative. In this case, we can do that just using the power rule. So bring the 4 down in front, giving us 4 times 5 is 20 as our coefficient. Subtract 1 from the power. Bring our 2 down in front, giving us minus 4x. 2 minus 1 is 1, so just x. And then the derivative of x is just 1. So then our second derivative would just simply be the derivative of the derivative. So now we want to find the derivative of this g prime here. So that'll give us g double prime of x. And to do that, again, we could just do power rule. So bring the 3 down in front, giving us 20 times 3 is 60 times x squared, because we lowered the power by 1. Derivative of a number times x is just whatever that coefficient number is. The x kind of falls off. And then the derivative of 1 is 0. So that'll just go away, basically. And then finally, to find the third derivative, that would just be the derivative of the second derivative. So then g triple prime of x is going to be, bring the 2 down in front, again, just power rule, bring the 2 down in front gives you 120x, lower the power by 1 just makes it an x, and then the derivative of this constant 4 is 0. So we just end up with 120x as our third derivative there. So I hope you found this video helpful. If you did, be sure to give this video a like, subscribe to my channel. We're going to be going through several more topics and practice problems from the Elite Guide to AP Calculus AB in the coming weeks and months. So be sure to check back for those and go grab yourself a copy of my book in the meantime. Thanks and see you next time.